All right. So my name is Carter. I was the P2 circuit rider for this summer. So as a circuit rider, I had a pretty different experience. I wasn't at just one company. I actually got to go around to a total of 8 companies this summer. I'd spend a day or two touring the facility with staff there or with and usually with someone else, typically Chris, but I've also been on a visit with Nancy as well. So I would spend a day touring, looking for ways to reduce their energy or water consumption, change some process, as reduce the use of harmful chemicals, or just look for projects that I could work on in the future. This provides economic savings for companies, can reduce their environmental impact by having less harmful chemicals that they release, having less energy that they use means less energy that a power plant needs to produce, means less emissions from there. So all good. So in total, I visited 8 facilities. I had 28 unique projects, unique in quotation marks, because some of them were repeated projects that I did at different companies. But these little dots kind of represent roughly where I was traveling to. So I got to go all around driving, which was quite the experience. And so I got to work with a gym, a dairy farm, a greeting card manufacturer, a cabinetry manufacturer, a metal fabricator, a flour milling facility, an iron foundry, and a work tool manufacturer. So quite the spread of different facilities. Is a lot of unique processes, a lot of different challenges that come with each different industry. Yeah, so here's a couple of the project categories that they mainly focused on. So we did LED light conversion and looked at occupancy sensor savings, looked at the efficiency of some fans, and compressed air audits and compressed air valves. So the first suggestion that I typically would ask at a company would be if they've converted their lights to LEDs from fluorescents. Most had, but a few hadn't, or a few were in the process and wanted some advice on what savings they could expect. So I would go through the facility. I would count the lights, which is as fun of a project as you can imagine. Counting is go through with a ballast checker, which is the photo that for you is on the left, for me is on the right. And go through count, but the ballast checker could check whether the fluorescent lights had a magnetic or electronic ballast, which just affects the energy consumption of the fluorescent lighting, and I can use that for calculations later. So the pictures up here are a few. I think the leftmost photo is a picture of some LED lights that one company had that they were replacing their lights with. The middle picture is just one of the fixtures. So I think that one had 8 tubes in one fixture. But each of those tubes has their own energy consumption. And so you can't just count the fixture, you have to go in and count the actual bulbs themselves, which changes the energy consumption there. And then the total savings I found was 177.982 metric tons of CO2 emissions, 183,629 kilowatt hours, and $15,162 in economic savings by replacing all lights from fluorescents to LEDs. Another project I looked at, which is kind of in a similar line, was installing occupancy sensors. So at one company, I got to install some data loggers that check whether there are occupants and what the light level is in a certain area. So that then allowed me to get a rough estimate of how often that place was in use versus how often the lights were left on. And so you could get an idea of how much money you could save on a yearly basis by installing sensors that would just flick the lights on after if a person walked in. And so that was a nice project. The picture on the right is one of the occupancy sensors I found that was for high bay ceiling, so it could be installed. I think it was about 20 feet heat up in the air and could detect a pretty big area, which is pretty useful for a lot of these companies that have the ceiling is pretty high up. But you can't just, you have to make sure that the occupancy sensor can actually detect the floor or itself. So from the occupancy sensors, there was a total savings of 12.54 metric tons of CO2 emissions, 12,938 kilowatt hours, and $1,789 per year. The most common project I worked on was compressed air leak audit. This was, I think I did it at 5 total facilities. I would take the UE system, which you can see in the picture up on the top. Up you go around across the airlines, and that sends out a little ultrasonic pulse that detects whether there is air leaking out of a pipe. If there is, it shoots you back a decibel reading, so you can tell that this leak is a little worse than this one. This one is less bad. And then there's an app that goes along with that system, and that was developed by the same company, that then turns that decibel reading into the annual cost based on the price of electricity that that company pays. So it's a pretty quick and easy process, but the calculations are pretty quick and easy, but the going through the entire facility takes a bit of time, as a lot of companies use a lot of compressed air, have very large lines. The leaks I found were mainly near connection points between pipes. So where there's two pipes that are joined together, where a pipe branches off into two, that's typically where you're going to see the connection, where the connection isn't fully sealed all the way, it's not tightened quite enough. But that is typically where I found them, but I also found them leaking out of just someone left their compressed air gun on and leaks in just along the main lines itself. So they can really be anywhere, but most common they were near those connection points. I found a total of 84 compressed air leaks. And then I also, at one facility, they have some gas tanks that they use for different processes. So there's an oxygen tank, a nitrogen tank, and then a tank that was a mix of argon and CO2. And I found 4 leaks from those. Which was a bit surprising. And the total savings I found from the compressed air audit was 371.175 metric tons of CO2, 382,951 kilowatt hours, and $21,927 per year. So pretty sizable when you add up that many savings just by fixing a little hole in your compressed air line. The next project that I looked at was installing compressed air valves into different compressed air lines. So these are something you can put right at the exit of the air compressor itself. And it's set on a timer system. So when the facility is not in use, say they shut down for the weekend and aren't working, then you can just set, okay, on Friday at 8 p.m., I want you to close off the compressed air line. It then closes off the line from the tank itself. So the air compressor is still on, it's still running, but the air compressor is just set to fill up enough compressed air to fill its tank. So if that air compressor tank is full, it's not leaking out to the system, you're paying less money in general, well, because the air compressor doesn't have to work as hard to provide as much air. And closing off the system itself then means you lose a lot less money due to leaks, because if you have a system that's open and running, the entire system can still be losing air from the leaks, and then the air compressor has to keep running to provide air that's then being lost by the leaks, and so on and so forth. So this was a pretty good thing. And you can get timers for the air compressors themselves that shut down the air compressors, but those I found were only for newer systems that have a microprocessor in them, and most places I worked with had air compressors that were installed in the 90s, installed a long time ago. And so this is an option for any system, not just your newer systems. There was a total of 10 air compressors that I found that could fit. These valves only go up to an exit diameter of 2 inches. Is any larger pipe than that can't really be safely closed off. So that's a little caution for the system, for these valves. Those they aren't for every system, but they do go 1 or 2 inches and work quite well with that. And that the total savings I found with that was 99.268 metric tons of CO2 to 102,417 kilowatt hours, $5,831 per year. Now these savings are kind of a little star next to them, because if you do fix all of the leaks in the facilities, then there's less, then these savings go down because there's less leaks in general. And these savings are largely based on the leaks that were found in the system itself. So there's a little caveat next to these savings. One of the final projects I looked at was at one facility. They have 4 different types of fans at their facility, and they wanted to know which was the most cost effective for both providing just energy wise, but also for providing the airflow and cooling to their facility. So they've got that, I'll just go left to right. They've got these very large ceiling fans that were like, I think they were about 20 feet in diameter. They're so very large, very big. They provided a lot of good airflow, but they were much more expensive than the other fans, at least to initial cost. Then they had these, the middle 2 pictures are smaller fans that they had just installed as needed, as a worker complained, oh, my area is too hot, that they throw up one of these fans as a quick solution to cool them down and prevent that heat exposure. Or they were less expensive, but still pretty decent. And then they also had these little standing fans that were dotted throughout the facility. And they want to remove all of those standing fans because they just pose a tripping hazard. They're not that efficient. And the wires, they would have wires that were about waist height and then go up to the ceiling thing. So that was fun to step over. And Joe knows because he was there with me. But what I found was all of these fans had about the same energy cost per year to run. And so, but the large ceiling fans while they were the same energy cost per year, they covered the same space as about 6 or 7 of the smaller fans in air cooling. And so if you compare the 6 of these smaller fans to one of the big fans, and you get a pretty quick payback on installing one of these big fans. And so where possible, removal of these smaller fans with one of the bigger fans is suggested. They already had 3 of them, but they had space for at least 2 others. I saw a space that could easily fit them, but they could easily find a few others. The total savings I found for these was 34.301 metric tons of CO2, 35,389 kilowatt hours, and $2,956 per year. There were also some additional projects that either needed a bit more research or weren't quite sure if they would be great for the company. One of the challenges with being a circuit rider is I do only spend a day, maybe 2 at a company, so I don't always get to collect enough information to fully know whether a project is worth pursuing, whether it is cost effective for a company. So these are a few of the projects that I looked at, but didn't quite have enough info to fully recommend. So the first project was looking at a new bottle washing machine. One company I looked at, they wash glass bottles for reuse already, but they have a machine that was from the 1950s to do so, which is very old and probably not that energy efficient. And so, but they could only find these new machines that were, they said 400,000 was the cheapest they found. So I looked into seeing whether I could find something better, and I did. This one, I believe it's about 65,000 and can process bottles at the same efficiency. It didn't have too high of an energy cost or water cost, but that's largely based on what the company needs themselves. So the energy consumption is based off what the company sets. That's the facility or what the company needs. So there's a range of values that I got from the manufacturer. But this was a pretty cheap in the sense of not 400,000, and that was pretty good, pretty nice find. One of the next projects I looked at was absorption chilling. This is a thermodynamic process that absorbs waste heat and uses that to convert it into cool air that can be sent out as essentially air conditioning. So I talked to one guy that was it was kind of like an expert in the system and these, but what he explained to me was that these are only really great if you've got a very large or consistent stream of waste heat or waste hot water. And so it's not very cost effective. It wasn't very cost effective for any of the places that I looked at. I also looked at solar absorption chilling, which is instead of waste heat, it just absorbs sunlight and converts that into cool air. And these systems are pretty good. I liked them initially because they don't have an electricity consumption. They just use that waste heat as their power. So that was something that I was looking into, but it just didn't work out. They didn't provide enough savings and weren't very cost effective. One of the next things I looked at was looking at the use of refrigerants at one of the facilities. They were using a refrigerant meant for chilling their water and some food that they had. And so if you go onto the EPA sites for significant new alternative policy rulings, they list out what refrigerants are acceptable for which processes. And I found based on the latest ruling regarding this, is the refrigerant that they used was acceptable. So I was able to report that they were totally fine using what they were using. One of the next things I looked at was one facility was using a few different solvents in their cleaning their painting guns. So they said that they used xylene and MEK. So I never got info on how much they used or how often it was used, but I was able to find that xylene can be replaced with dimethyl carbonate 99%, and MEK can be replaced with amber clean 527L for certain processes. If I wasn't able to get that much information about it, so these are only the possible replacements, but this would reduce their hazardous chemical use and provide a little safer workplace environment. And because at least xylene is a hazardous air pollutant and so isn't great to have leaving evaporating out. And one of the next things I looked at was a new type of energy efficient roller mill for some facilities. So this is a new process that it's instead of having just one motor for roller mills, this is for the flour milling facility. This is a 2-motor system that has a slower motor and a faster motor. So the slower motor is a bit less energy efficient and releases some waste energy that is then captured instantly by the fast motor, leading to a lower overall energy consumption, and which means you can just have just lower energy consumption in general. And this is just one motor is like decent savings, but when you consider how many motors that they had in the overall milling facility, this would be very large scale. But I wasn't able to get too much information from this facility about how many motors they had, how much that they used. Another thing I looked at was getting a multi-impact hammer mill, which is just a more efficient hammer mill, not necessarily more energy efficient, but more efficient process of creating ground flour itself. So instead of having a faster spinning hammer, which the hammer spins and knocks the grain particles into a grate, which then takes the fine flour particles out of the system. And typical thought was the faster the hammer spins, the more efficient you have of creating flour. But this company found that if you actually decrease the hammer speed, but introduce a cutting plate, which doesn't allow any flour to escape, but just knocks the grain particles back, you can increase the rate at which the particles hit the hammer. and you can decrease that hammer speed, which leads to less heat generation, less friction, and less wear and tear in your machines, and it actually leads to more efficient flour making. One final thing I looked at was some variable speed motors. So this is just motors that have multiple different speed settings to match the need of your process. This allows you to have some energy and economic savings, because you can set, instead of setting all motors to max speed, if you only need a motor to go half speed, that then allows you to reduce your energy consumption by not having it use as much energy to go as fast. So these savings are largely based on your process, but can be pretty sizable if you use a lot of motors in your company. And then overall, all these savings that I found just from the projects that I've got numbers on was 695.265 metric tons of CO2 emissions reduced, 717,324 kilowatt hours, and $46,331 per year. And I will now open it up to questions. Yeah.
Can you tell me which type of facility had maximum savings?
It's a bit hard to say because but I think one of the companies that I had with compressed air would be highest. There's a potential that the LED light conversion was the highest, but that might just be due to the sheer amount I was able to get of their lights. I don't know off the top of my head which one had the highest, but I would say probably one of the compressed air. Yeah.
And which project did you enjoy the most?
Initially it definitely was very interesting learning about the absorption chilling. It didn't pan out that great, but it was interesting to learn about the process, and it was a cool thing to learn about.
Question. So I enjoyed your presentation, and I was curious about the air compressor valves that you had recommended. I guess maybe two questions. One, do you know roughly what the cost of those was?
Yeah, I believe I know off the top of my head that the 2-inch one is about $1,321. The 1-inch one I think was about $650. So not the most expensive.
Yeah, I would say. Okay. And then second question on that, were you able to find out were the businesses actually just leaving their compressors running then over on the weekend holidays? Is that kind of common?
Yeah. Everywhere that I've talked to said that all but one company, one company did great. They turned it off when they were done. But most places said, no, we have to leave it on, and it takes too long to start pumping it back up. We don't want to have our people come in an hour earlier to turn on the machines. We don't want to turn it off. The system is too big, but if you come in on the weekends, you can hear the hissing through all the leaks.
Thank you.
But I'm happy to see the dollars, the savings then.
So that's one thing that since I only spent one day, I never got to really tell a company or see a company's reaction when I said you could save this much money, because I would spend a day there and then I would go back home and do all the calculations, do my research, and I wouldn't have too much communication with the company after that.
Okay, I have a question about your air compressor. You talked about how the bigger ones can't work with the monitors. Did you come up with a solution for those, or just that sucks?
I wasn't able to find one, but everywhere that I worked with didn't have larger than 2-inch diameter. So I was able to recommend it to all the companies. But it was just when I was talking to the person that actually told me about these valves, he just mentioned if you do have a larger than 2-inch diameter system, it's not that recommended. So I never had to say, oh, it won't work for this system, but it was just here's a caution, it won't work for everything.
Yeah.
I know you had the opportunity to work in a lot of hot conditions this summer.
Yes.
And so, thank you for all your work that you did, with those 8 companies. That's impressive for a circuit rider to be able to get to 8 places. That's a lot. So thank you for all that work. And I know that, when you talked about conversion to the LED, were most companies wanting to do it in a process where, as they have failures, they make the conversion? Or did you have any companies that were interested in doing a full over conversion all at once?
I think most of them were just in the most places I would go to were, they would say, we've already done it or we're in the process. That's just as the lights die, we replace them. But I know one company did ask for, I want to know what the payback period would be if we replaced all of our lights right now. So I think once they saw that, I think they would probably go through with replacing all of them at once. But at that point, they were just slowly replacing them as they died.
And a follow-up, so when you recommended replacing everything all at once, did you consider getting rid of the ballast as well?
Yes, so I looked at initially what the difference was between just installing LEDs with the ballast still in and with the ballast out, and most often it's just far better to remove the ballast and just keep them as LEDs, as that's just a far lower energy consumption. So I only really recommended removing the ballast for the LEDs.
And then I just had, are there any other questions? I have one more, and really more of a statement too, is, well, a couple of things. I want to compliment you on your use of some of the EPA tools and mentioning those. There's a lot of EPA tools out there that we sometimes forget about. So, so thank you for that. And then, the other thing that I'll just say is that a lot of the, host companies that we have that are permanent now started out with the circuit rider. So the kind of work that you're doing with new companies, and I know the one we went to, they are very interested in having an intern next year. They said they sold it and they want a full-time intern next year. So be sure to pass any of those on to Chris, because they'll go into our outreach database. But of the 8 companies, and I know one was a real small project with the gym maybe, but how many of those do you think would have enough projects to host a full-time intern?
I think a good amount of them would. But when I would show up to companies, there'd be a lot of, I don't really, what you could work on. I don't know how many projects there could possibly be. I think we're doing pretty good. But then as you spend a day going through and walking through the facility, me having learned all of these ways that someone could improve, I can easily see, oh, LED lights, compressed air, or you have a lot of waste heat from this thing. You have a lot of wood waste from this. You have this thing that can be improved, this thing that could be improved. So I think most of them could benefit. That I think that's also one thing that, just me personally, if I could spend longer at a company, I could do these bigger projects that I can think of, but only having the one day makes it difficult to do much more than these easier projects in a sense.
But all of those projects were reported in the report to the host company, right? So,
Yes.
yeah,
Oh, excellent.
yeah.
Any other questions? Any questions from the audience? Okay, well, thank you, Carter.